Hello, and welcome to Passing College Level Chemistry. Today we will be focusing on density. The problems that I'm including in this video are coming from Pearson's Principles of Chemistry, a Molecular Approach, the 3rd edition, and they're indicated as such as here. So to start off, I'm just going to write a couple things about density on this slide. Density is abbreviated as a lowercase d, or you may see it as the Greek letter rho, which looks like that. Looks like a fancy P. Density is an example of an intensive property. I'll write that here. An intensive property just means that whatever the property is, in this case density, it's going to be independent of the amount of a substance present. So an example would be titanium. Titanium is abbreviated Ti on the periodic table. Titanium has a density of 4.51 grams per centimeter cubed. And I could have 1 gram of titanium, or 1 kilogram of titanium, or even a liter of titanium. No matter the amount, my density is always going to be the same. So just say always the same. It's independent of the amount present. It has an equation. You might have seen, this says grams per cubic centimeter. That's a mass divided by a volume. You can also see it written as m over v. Density has the units kilogram per liter. These are actually the SI units. SI stands for the International System of Units. So mass has an SI unit of kilogram. Volume has an SI unit of liter. And so if you're looking up something, you might see kilograms per liters. More commonly, though, we're going to be seeing a lot of grams per cubic centimeter or grams per milliliter and units like that. One unit conversion that is particularly helpful when dealing with density is the conversion between milliliters and centimeters. And it's actually equal to each other. So that makes our lives a little simpler. No complex numbers, it's just 1. So this density here could also be written as 4.51 grams per milliliter, because a centimeter cubed and a milliliter are equal to each other. Now, why is this important? Why is density one of the first topics that we talk about? It's a good example of how we can conduct an experiment, and how we can use density to determine whether or not something is what it is claimed to be. An example would be, suppose you were walking around outside and you came across this nugget. Alright, nugget. And you're looking at it and it kind of looks like gold. Gold is abbreviated AU on the periodic table. You might be wondering, is this in fact gold? How can I figure out for sure if this is gold? Could I sell it? Maybe it's a pretty big gold nugget, and you want to know if it's worth something. Well, there are scientists and people who have gone through and they have actually calculated densities of pure substances, one of which is gold. So the density of pure gold is actually 19.3 grams per cubic centimeter. And we can figure out if this is pure by calculating a mass and calculating a volume. If it's a cube, we know that's just length times width times height, and a mass we can just weigh it on a balance. So suppose that we found this mass is 22.5 grams, and the volume came out to be about 2.38 cubic centimeters. I can go ahead and calculate the density. I would just do that by dividing those numbers. And it's going to come out to be about 9.45 grams per cubic centimeters. So I found out, okay, that's the density of this nugget. This nugget then is not pure gold. Why? Because the density of pure gold is 19.3. The density would have either had to be much larger, the mass would have had to be much larger or a much smaller volume to be considered pure gold. So that is one way that density can be used. It also gives a sneak peek towards another math concept called stoichiometry, which I will cover in a future video. But lots of good stuff. So that's just sort of a preview of what density is. Now your teacher or professor will probably go into much further detail, but this is sort of an overview of what we're doing. So this is a textbook problem. This is coming from chapter 1, question 30 at the end of the chapter problems from the Pearson textbook. And this is an example of a unit conversion density problem. We're told that a titanium bicycle frame displaces a volume of water, and it has a mass of 1.41 kilograms. It's asking for the density of the titanium in grams per centimeter cubed. When I am given a word problem, my high school teacher actually told me this, and I've carried it with me through college. He told me to always break down a problem into 3 parts: a given, a find, and this part's optional, but if there are any useful equations, and I'm just abbreviating equations as EQ apostrophe NS. So in this case, I was given a volume of water, and I'm writing my units down. Units are going to be important, always important to write the units. I'm also given a mass. I'm identifying what each unit belongs to. That will help you figure out equations. So when you're looking for possible equations, you might be like, well, okay, I have a mass, I have a volume, I could use a density equation. Just so happens that we are asked to find density. Big shock in this question. So now everything is filled in. I am going to make one additional note. They're asking for the density in grams per cubic centimeter. That is important because if we're looking at over at what we're given kilograms and liters. That's not grams and cubic centimeters. So we're going to have to do a little bit of conversions. I'm going to show you 2 ways that you can go about getting those conversions. Way 1. I'm going to break it down to mass. I'm given a mass of 1.41 kilograms. I need it to be in grams. So what is something that I can multiply or divide it by to get to grams? If you recall from unit conversions, it means that there are 10 to the 3rd grams in 1 kilogram. Or you could see 1 gram equals 10 to the negative 3 kilograms. Both are equal. You'll get the same number no matter which one that you use. I'm going to go ahead and use this first option. I don't really like using negative exponents. I feel much better using positive exponents, so we're going to stay positive today. Go ahead and do that. The reason I'm multiplying it by 10 to the 3rd grams and dividing by 1 kilogram is so my kilograms cancel out. It's a big theme. You want to get into the habit of canceling like terms. And this will end up giving me 1,410 grams. Now I have the correct unit. Just write that like this. And now I can deal with the volume side of the problem. I was given 0.314 liters, and I need to somehow get to cubic centimeters. If it helps, you can do a little brain map. Be like, okay, I have liters. I somehow need to get to centimeter cubed. I know that from that last slide, I gave milliliters. I know a conversion that can get me back and forth between milliliters and cubic centimeters. They're equal to each other. And I also know that there are 10 to the third milliliters in 1 liter. This is another example of a metric prefix. My base unit in this case is liter. My metric prefix is the milli. And there are 1,000 milliliters in 1 liter, or 10 to the third milliliters in 1 liter, or you could have 1 milliliter equals 10 to the negative third liters. Whichever one that you are comfortable with will work. So I'm going to go ahead and I'm going to work this out. I'm going to make a big fraction. I call these train tracks. I find it a little easier just to write everything in the proper way instead of multiplying multiple times and getting confused by each individual fraction. I have to get rid of those liters, so I want my milliliters to be in the numerator. Whatever you're trying to get rid of, you're going to want it to cancel out. So in this case, I want liters to cancel out, so I need to make sure I put my milliliters in the numerator. Now my liters cancel out, I'm left with milliliters in the numerator. However, I don't want milliliters, we want cubic centimeters, so we can go ahead and do that one conversion factor from the previous slide where they are actually just equal to each other. Now my milliliters cancel and I'm left with cubic centimeters. Doing this will give you 314 cubic centimeters. And now, go ahead and highlight. I have my mass and my volume in proper units. I can go ahead and divide them. Okay, my density then is going to be 1,410 grams divided by 314 cubic centimeters. When I go ahead and solve that, I get 4.49 grams per cubic centimeter as my answer. And if we compare that, I had given you the density of pure titanium is 4.51 grams per centimeter. So this is actually a very good measurement. Whoever took these measurements was very, very close to the true density of titanium. Now I told you I would show you a second way. Second way that we could have solved this is done everything in one step. So I know my density is mass divided by volume. I had that mass of 1.41 kilograms. I'm going to make a big fraction. I'm going to put my volume below it, which was 0.341 liters. Or I'm sorry, 314 liters. Alright, so now I'm just going to convert each unit. Now this way might be a little more tricky, so I'm going to write my mass in red, my mass conversions, and then I'm going to leave my volume conversions in black. So we know from the previous slide that there are 1,000 grams in 1 kilogram. So I can go ahead and just plug that in. I want to get rid of those get rid of those kilograms. So I'm going to put my grams in the top, my kilograms in the bottom. Now kilograms will cancel. I'm left with grams in the numerator, which is what we want. We want grams per cubic centimeter. So this looks good. Now I'm going to switch over to volume. We need to get from liters to milliliters to cubic centimeters. Instead of everything being what we want on the numerator, in this case, we're going to want everything, the units that we're trying to solve for, to be in the denominator. So I'm going to put 1 liter at the top and 1,000 milliliters in the denominator. Now my liters will cancel. They're still canceling because there's liters in the numerator and the denominator. I'm left with milliliters in the denominator, which is good. We want that. And then I can go ahead and convert to cubic centimeters. My milliliters cancel, and I'm left with cubic centimeters in the denominator, which is what we want. This is a preview of stoichiometry, converting between units. This is good practice. I can go back and just double check everything looks good. Kilograms cancel. I'm going to highlight what I'm left with. So here I'm left with grams in the numerator. And then we did all of our volume conversions. Everything cancels nicely. We're left with centimeters in cubic centimeters in the denominator. This looks good. I can go ahead and punch this into my calculator, and I come out with the same answer. So whichever way you're comfortable with, if you're just getting started, I would recommend doing this way, where you break it down into its components, the mass and volume, and then putting it together. Put together here, and then solving it as such until you gain that confidence. A lot of this is just practicing until you're confident, and then you can approach the problem and knock it out. Alright, this is the last problem that we're going to do. This is a two-part problem. So we're told acetone has this density. It's given to us in grams per cubic centimeter. In part A, it's asking what is the mass in grams of 28.56 milliliters of acetone. And then in part B, it's asking for the volume of a mass of acetone. We're given this density, which we can use in both parts. 7.857 gram per cubic centimeter. In part A, we're also given a volume, 28.56 milliliters, and we're asked, whoa, got very close there, we're asked to find the mass in grams. Now I can still use that density equation. We're just going to be rearranging it. So density equals mass divided by volume. The way that I can rearrange this, in part A, we're trying to find mass. So what I like to do is whenever I'm given a problem with different units and components like this, I like to isolate what I'm solving for. In this case, I'm solving for mass. I'm going to rewrite it over here a little bigger. In this case, I want mass. So to get rid of it, or to get rid of the volume and isolate the mass, I'm just going to multiply both sides by volume. Volume will cancel on the right side of this equation. Whatever you do to one side of an equation, you have to do to the other if there's an equal sign. So we're doing some algebra here. This will give me a new equation where mass is equal to density times volume. And we can go ahead and use this newly written equation to solve part A. Checking just to see if I can go ahead and plug. I can't because of my units of volume. I look, my volume is given in milliliters. My density is given in centimeters. However, we know that 1 milliliter equals 1 cubic centimeter. So we don't really need to fret. I can kind of just cross that out, put cubic centimeter there, and now I can plug into my new equation. So we're going to go ahead and do that. I'm going to say my mass. I'm trying to write it at the top so I can write part B at the bottom. Okay. It's going to equal my density. 0.7857 grams per cubic centimeter times 28.56 cubic centimeters. Now looking at this 28.56 is sort of over. We remember, this is again another algebra thing. It's in the numerator. It's divided by an invisible 1. We don't really write the divided by 1 part, but in this case we can see that in so doing, our cubic centimeters cancel. We're left with grams, which is what we want. So I can go ahead and convert this. I don't really have to worry about the conversion to anything else because we're solving for grams. And this will give you 22.44 grams. That's for part A. In part B, we're given, in this example, we're given the mass. We're given a mass of 6.54 grams of acetone, and we're asked to find the volume in milliliters. Once again, I'm going to take that density equation. In this case, I want to isolate my volume. And to do so, we have to do a little more rearranging than we did in that first problem, but it's okay, we can do this. I'm going to first multiply the volume by both sides. It's going to get it out of the denominator and into a numerator. So this gives me a new equation of dV equals m, which is what we had up here. Now I want to isolate my volume. I don't want density to be near it in this case. So what I'm going to do is I'm going to go ahead and divide both sides by the density, or multiply by 1 over d. This gives me a new equation of volume equals mass divided by density. I can go ahead and use that equation. Switch colors. My volume is going to be 6.54 grams times, I'm going to separate it into mass times 1 over density, just so that we can see how things cancel. So I'm going to have 1 over my 0.7857 grams per centimeter cubed. I have a fraction with a fraction of units. If we go ahead and did that math, if we remember, whenever we divide by a fraction, we just multiply that top part of the fraction by the reciprocal of what's in the denominator. So in this case, I would multiply the numerator and denominator, which is a fraction, by centimeter cubed divided by grams. This will cancel everything in the denominator. This all comes out to be 1. And my numerator is now centimeter cubed per gram. So really, this looks very ugly here, but this volume would really be 6.54 grams times 1 divided by 0.7857, and then centimeter gram, like that. Another way you can solve this, maybe you like this a bit more, is you could take your 6.54 grams, we're still solving for volume, and use those train tracks. You put 0.7857 grams in the denominator. We're dividing by the density, and put 1 centimeter cubed in the numerator. We're just flipping density. So this will also give you the same answer, and then your grams cancel. Density is a fraction. We write it sometimes like this up here, but it's really 0.7857 grams all over 1 centimeter cubed. This is going to come out 8.32 milliliters. Okay, so this was a good problem, good example of how you can rearrange equations. And we're going to get a lot of practice with this. This is sort of just an intro. It's my first video, so please let me know what you guys think. If you'd like to see more example problems, I'd be happy to make another video like this, but that's what I got for you guys. Hopefully this gives you an idea of what you might see in a homework assignment or a quiz, an exam maybe, depending on your level. But yeah, thank you for watching.